So we'll bring up our panelists. This is a conversation on the kind of frontiers of securing the internet and kind of the political issues underneath that. And it really fits into this theme of only just beginning, because as so much of our lives go online, if the infrastructure and the culture isn't there to support trust, progress isn't made. We have Tobias Engel, who's very well known as one of the top hackers in Germany, and last year discovering kind of a major security flaw in the global cellular network, made a lot of headlines in exposing that, and is now starting a venture to address it. It's kind of the very embodiment of cultural white hacking. And Dan Kaufman heads software research for the Defense Advanced Projects Agency, comes from Microsoft and DreamWorks, a fascinating perspective on the culture of leading this kind of research in the United States government. So gentlemen, let me throw it over to each of you, and then we can get into a conversation. Tobias, we'll start with you. Why don't you tell us a bit about kind of the background of hacking here in Germany, and then your odyssey of the last year?
Well, I don't know the background of hacking in Germany. I mean, I'm an active member of the Chaos Computer Club that some of you may know, and which has a really high standing in Germany, and we have a large conference at the end of every year. And as a member of the Chaos Computer Club last year, a friend of me and myself, we started looking into security of cellular networks. And yeah, we were very amazed by what we found and what the consequences are, because we are all talking about internet security and what you can do to secure data on the internet, but we all have these phones with us every day, all the time, that are practically tracking devices. And yeah, so you can intercept calls, track people, and it's not, nobody's talking about that.
Well, why don't we go ahead? I know you have some thoughts on a presentation.
Yeah, microphone.
Let's, I was going to say, I think you have a presentation, you can share some stuff with us.
Yeah.
Nico, who runs Wicker, couldn't be with us. Wicker is a secure messaging system. I actually first met Nico when I was introduced to a bunch of North Korean defectors who were basically trying to recruit people in Silicon Valley to help them figure out how do you penetrate that land. It was the talk that I gave earlier. And I never used Wicker. I never used a secure messaging system until I started working on that project. And then it was this week, as I was using it a lot, that I noticed that David Cameron, and then evidently later the president of the US, came out against secure messaging, encrypted messaging, which made me realize I was an enemy of the state, though I couldn't quite realize which state. So it's a rich area. So go ahead and share kind of your thoughts on what you've been up to.
Okay. So I don't know. I'm going to talk about mobile phone security or mobile phone network security. I want to start with a question. Who of you has ever heard before today of SS7 or signaling system number 7? Okay, some people, not bad. Okay, so every one of us has a mobile phone, and we use SS7 every day. Our phones do, the mobile networks do, because those are the protocols being used by the mobile telco network operators, switches and databases to talk to each other. Meaning, every time you make a call, one switch tells another switch, hey, I have a call from number so-and-so to number so-and-so. Or if you move to a new area, for example, when you came to Munich and switched on your phone contacted the local Munich switch of one of the 4 German network operators, and the Munich switch contacted your home network and your home database there and asked, who is the subscriber, what's his phone number, and what is he allowed to do here? So it's really a global network, yeah, that's been around for, okay. It's a global network that's been around for a really long time. It's been designed in the 70s. It's in use since the 80s. When it was designed, there weren't really any there were only few big telco corporations, mostly state-owned, and they all trusted each other. So there was no security built into these protocols. And fast forward to today, we all have mobile phones, and these protocols have been vastly extended to support moving around, because we all expect our phones to work wherever we go on the planet. And prepaid billing, text messages, internet, and so on. And thousands of companies have access today, and getting access is easier than ever. But the security is still the same as in the 80s. There is basically none. If you have access, you have access. So, okay, this has privacy implications for all of us. Because now there are companies offering tracking of people just by knowing their phone number. So they have these products called Infiltrator or Skylog, and they are offering, we can create movement profiles of people if you just give us their phone number. So why does this even work? The mobile network has to know where you currently are, because you want to receive calls, you want to receive text messages. So the mobile network has to know which cell tower is currently closest to you. And if an attacker can find out the ID of that cell tower, he can look up the geographical location of that cell tower in one of several databases. So I think Google maintains probably the largest of these databases in the world. And so if the attacker finds out where the cell tower is closest to you, he of course also has a pretty good idea of where you currently are. So it's possible to create near real-time movement profiles of people just by knowing their phone number. And you don't even have to be in the vicinity of these people. You can do it from every telco in the world can do it, or people with access. For example, somebody from North Korea could do it and track you right here, just as an example. In some networks, it's even possible to remotely activate the phone's GPS receiver and return the precise GPS location back over the network. Okay. So just to illustrate that, we did some tracking of our own. Can you see that? Yeah. Here you can see somebody traveling through Germany. It starts up there in Darmstadt, goes down south over Karlsruhe, Stuttgart, Ulm, Munich, and then up north until Leipzig. And we only took samples once every hour. But we could have requested a location every minute, for example, would have been even more precise. And you can even see which autobahn the person took. And as I said, this works globally. So here is somebody who lives in Seattle. You can see which street he was in. And we never knew more than the person's phone number. So, and we also talked to some network operators about this. And they told us they're seeing, I mean, at first they were really amazed because they didn't know about this. And then they started monitoring, and they said they're seeing a lot of tracking of people. So one network operator from Southern Europe even told us they're seeing a lot of tracking of politicians' phones, for example. So, but it's not only possible to track people, it's also possible to intercept calls. So SO7 is a signaling network, meaning there's no voice data or internet data traveling over the network, but it's used to set up calls. It's the metadata. But it's also possible to reroute calls. So, for example, if you want to call a friend and you dial his number, an attacker could simply reroute the call to one of his own phone numbers. From there, he could connect the call back to the number you originally dialed, being the man in the middle and recording the whole call. And this is also something that's actually happening. So an Ukrainian operator, for example, found out that some of its subscribers were being tracked by a Russian network. or intercepted. Its calls were being intercepted by a Russian network. The same holds true for short messages. So several banks now use text messages for one-time passwords or mobile transaction numbers. It's a second factor of authentication. So you log into your online banking, say you want to transfer money there, and then you get a text message on your phone and have to enter the password you have been sent into the online banking interface. So if the attacker can divert the text message to himself and he steals your online banking credentials before, he can transfer money into his own account. So something like that actually happened in Germany a few years ago, but the criminals actually ordered new SIM cards for their victims' phones so they could get the short messages. If they would have known that, they wouldn't even that wouldn't even have been necessary. Okay, it's also possible to commit fraud by activating call forwardings in your phone. So, for example, the attacker could activate a call forward to a premium rate number in your phone, and then he would just dial your phone number, just paying the regular charge, and you would get the bill for the divert to the premium rate number. Again, all by just knowing your phone number. So, yeah, it's also possible denial of service in many ways. You can disable incoming or outgoing calls, can disable short messages, can disable the internet, and you don't see anything of that on the phone. It just looks like it always does with full reception. Okay, the big question is, what can you do against it? Problem is, you as a customer cannot do much because it's a network issue, right? So it's nothing that happens on your phone. You don't have to have a smartphone for these attacks to work. It's just a $10 dumb phone also is vulnerable to these attacks. It's just something that happens in the network. So if you are planning on going to a meeting that nobody should know of, then switch off your phone before traveling to that meeting. Not only before the meeting starts, but before going to that meeting. And also don't give your phone number to everybody, because these attacks are really happening, and then they can affect everybody who has a mobile phone, and it covers the whole world. So the real solutions have to happen in the operators' networks. So as a first measure, operators can remove the need to, they can change the call and short message routing in their network, so that they don't have to hand out so much information to everybody who asks via SS7. But as a real solution, you have to install firewalls, application-level firewalls into SS7 networks, because I mean that's something we've been doing on the internet for a long time now, and so SS7 is this other global network where nobody seemed to look at security for such a long time. So yeah, to sum it up, SS7 is a global network. You can track people, you can intercept their calls, all just by knowing their phone number. So yeah, be careful of where and when you use your phone.
I have a question on when you kind of talked about this last year. Were aspects of this the things that law enforcement have been using, metadata they've been collecting for years, and so what you realized is this was a kind of an open network and easy for anyone to get in, or are these methods that kind of people didn't know about?
Well, so we are definitely not the first ones to discover this. So as I said, this is happening, and operators now start looking, and they see this happening in their networks. And I mean, this is so obvious, these vulnerabilities. I'm absolutely sure that there are entities who have been using these vulnerabilities for a long time. So the biggest hurdle was to get access to SS7. But this has been getting easier all the time. for years, because there are more and more companies who need access. So you can just buy access. You can go to a telco and buy access because there are so many companies who need access. And yeah, but the security hasn't been keeping up.
This reminds me when I was a kid, before we all had computer networks, there was phone phreaking. There was hacking the phone network.
Exactly.
And it was done with something called in-band signaling. The control signals that ran the network ran on the same network that the voice did, and if you created a tone of 2,600 cycles, you whistled it, you could pop into the other network and using parallel sets of DTMF tones take over.
Exactly, you could talk to the switch. You could
right.
talk, yeah.
Now this isn't in-band signaling, it's a parallel band, but it's the same thing. Once the cat's out of the bag, someone else has the network.
Exactly, and back then in the 80s, they said, okay, so we're not doing in-band signaling anymore because it's too dangerous, so we are switching to out-of-band signaling because that's much more secure. And well, it's only secure once you don't allow access to that other band.
Well, Dan, what a lovely setup for how porous our networks are. Dan, so tell us a little bit about your background and also DARPA, which kind of has this legendary role of leading technology in the United States, and then the kind of the philosophy and the work that you're bringing to leading cybersecurity research.
Yeah, sure. I'm a pretty typical DARPA person, actually. So if you don't know DARPA, we're very weird. We're both very small and we're very large at the same time, right? How can that be? So here's why. All of DARPA is 100, on the technical side, it's just 100 of us, and you only come for 4 years. So most people like me come from a private area, so I was in Microsoft and DreamWorks, did games, things like Medal of Honor. So if you know 14-year-olds, I'm very cool. And then went on and had my own company actually based in Europe, and then got recruited to come into DARPA for a 4-year stint. So on the one hand, we're very, very small. And the reason I say we're very large is our budget is $3 billion a year. So both small and large at the same time. I run the software office, so it's about 535 million a year, something like that. About half the office is cybersecurity, much like the problems you're hearing today. And the other half is big data and big data analytics. To give you a little bit of a flavor of how we work, and obviously I can't cover everything we do, we sort of started fundamentals. We sort of look at, we hear and we listen over and over again about every attack. You can't live in this world without hearing about every day there's another attack. And so we took the step back and said, well, okay, so let's just be honest about it. Cybersecurity, as we know, is just fundamentally broken. It is deeply and fundamentally broken, and throwing more crap on top of it and more patches or more signature-based stuff is not going to scale and it's not going to work. So what are you going to go do, right? Because obviously we're not going to give up the wonders that are technology. So we started there. And then the second thing, and when I say it's broken, for people who don't understand, think about how crazy this is, all right? You go to a store, you pay them whatever, 2,000 euros for your new PC or Mac or tablet or whatever you have, and they give it to you, and what is the first thing the person tells you? As soon as you buy it, what is the first thing they tell you? They say it's broken. Okay, well, they don't use those words, because if they use those words, like you wouldn't buy it, they have code words. But here's what they say. They say, you should go get antivirus, and you should patch your system, right? It's the first thing they tell you, patch your system. Think about anything else in your life that you buy. You would never buy that way. You go buy your suit, and they go, first thing you should do is patch it. You'd say, why don't you sell me one without holes, right? If you sold your car this way, it makes no sense. And what we realized was, as bad as that is for the PC world, as we move into the Internet of Things, it's going to be that much worse, right? What does Patch Tuesday, in my case, looking out for the military right now, what happens when 10th Fleet is, storming towards Bahrain? Do we say, oh, it's Patch Tuesday, come home? Like, what do you tell them? What does it mean for your refrigerator? What does it mean for your car? None of this stuff makes sense. So, at DARPA, I don't believe in silver bullets. I don't think they exist, right? It's a fantasy to think that you will do something and that the bad guys on the other side sit back, do that slow golf clap like, oh, well played, DARPA. We're out of the business entirely. You have confounded us. So we've launched a number of different efforts, right? So very briefly, one idea says, why can't I make a computer correct in the first place? What if I could build an operating system that is actually based on security, that's fully secure and provably unhackable from the beginning? We're using something called formal methods. It's something correct by construction. We don't think I can scale today to a full operating system too big and too complex. People like him would mock me. But I think an RTOS, a real-time operating system, is small enough. The things that go in your cars and things that go in your refrigerators, we may be able to do. We're already doing it with an American-made car and with an Arduino copter, so we can put it out publicly to everybody. We've replaced about 60% of the code, which means doesn't mean it's unhackable, but it means that for security properties you care about, they're mathematically provably safe. So for instance, you should never be able to go from my entertainment system to my brakes. That just simply should not be the case. Today what you do is you test it, which means you pay a bunch of people not a lot of money, and then they spend a bunch of time, and then they get bored, and then you say, well, that's good enough. The difference here is this is actually mathematics. So one of the lines at DARPA we like to use is we like to replace trust with math. So this would just mathematically say there is simply mathematically provably no point from point A to point B. So that's one thing. A second thing we asked was, so why is it that the offense always win? Why does the offense always win? I mean, are we just on defense? Are we stupid? What's the story? So the answer is, part of the answer is that we do a lot of damage to ourselves as users. We live in a monoculture, right? So everybody either lives on a Wintel box, or you live within the Apple operating system, or maybe a few of my little nerdy tech friends out there, insist on their Linux box, but mostly that's it. And if we move one layer up to the application layer, it's even more homogeneous, right? We're all using some Word, or we're using Excel, or PowerPoint, whatever you're using, right? And so from an attacker perspective, they say, gee, if I can hit one box, I compromise millions or tens of millions or hundreds of millions. What if that wasn't the case? Right? So DARPA has this idea, and we said, hey, what if every single computer was slightly different? Think about it. Think about the human immune system. The reason we're not all dead from the bubonic plague is two things. One was our immune system slightly different, and two, it morphs over time. Why could computers not be the same? So this is sort of an insight to how weird DARPA is. So we're sitting there, and we have this idea. We think it's great. Make every computer different, and we're like high-fiving each other. It's the nerdy thing to do. And then we talked to our first IT professional, who looked at us like we had two heads. He was like, wait, let me get this straight. I can't manage my network today, and you geniuses want to make them all different. And we're like, yeah. But we think we can do this in a manageable way. So the idea is, we think at the low level, where the attackers come in, when you're looking at memory structure and the like, we can make that different. We call it binary diversity. And yet at the high level at Word, it would look exactly the same to you. So the idea is when you go down and download an application from whatever, the iPhone store, the App Store, whatever, the version you get would be slightly different. So that part we actually have up and working. The dream of making it so that it will adapt every single time you boot it up turns out to take too long right now, and so we're not efficient enough, and so it'd be a little frustrating, right? So I'll give you just a third just to give you sort of a picture. Third one said, we have another crazy idea. So people familiar with DEF CON? If you're not, DEF CON is like the cool hacker conference. It's my favorite. Other than you have to go to Vegas, but other than that, it's pretty good. So you go out there, and at DEF CON, there's this amazing contest called CTF, Capture the Flag, in which thousands of the best hackers in the world compete all year, and it boils down to the top 10. And those top 10 actually do a day or day and a half tournament in which they have to keep their computer up and running, and they have to be able to go and get information off other people's computers, all within this ring of 10. And they battle back and forth. It's the closest thing you'll see to actual cyber warfare. It's absolutely amazing. So one of the guys who does very well at the tournament, his name's Mike Walker, and I wanted Mike to come and work for me for a few years. And I said, hey, Mike, I'm just curious, do you think a computer could ever enter DEF CON CTF, And he said, no, that's just stupid. And I went, okay, well, do you know anybody who thinks that could happen? And he said, wait, if you're offering, I want to do that. So he's going to do it. So we've announced the largest prize money I think we've ever offered, about $9 million. We're going to hold the semifinals in June of 15, and then at the finals, we're going to actually co-locate with DEF CON. Now, we're going to start off, in fairness, we're going to start off much like Big Blue did, right? Remember Big Blue, the big chess thing? So when Big Blue started, everybody laughed at us, in the community and said, you're idiots. And in fact, masters of chess were told not to play because it was demeaning and beneath them. And so for 7 years, it was an all-computer league, just computer on computer. And then in 84, 85, Kasparov lost, and from now on, humans play for second place. Yeah. And then everyone said, oh, well, that's chess. That's a simple game. Obviously, people who've never played chess, but okay. It would never do well in things like large American, like a trivia contest. And then, Ken Jennings went down. So this is the exact same idea. So the idea is we'll start with just computer on computers, but eventually the idea would be to you would have software that would real-time be able to do static and dynamic analysis of the code and actually patch and repair your system on the fly in real time. So that's just a little taste of what we do, but hopefully that gives you an idea of trying to change the way we look at cybersecurity from what we have today, which I think just fundamentally doesn't work and doesn't scale.
So this is a conversation on securing data, and one of the great conversations recently is, do we encrypt our data? Do we let the government see our data? Do we stick it in secure stores so that big institutions don't get a hold of it? And I know you've been giving some thoughts to kind of both architectural approaches and conceptual approaches to this. Yeah, so, as technologists, I think it's very dangerous for us to ever comment on policy because, if I wanted to do that, I would have studied something else. I'm a big nerd, so I'm much happier behind a keyboard and a screen. I talk to my computer. But so when I listen to people talk, it struck me, forget the extremes, right? Extremes I always find uninteresting, right? But when you talk to sort of rational people, you hear two things, right? One is, gee, there are many times when it makes sense to me that I would want to share my information with either the government or a consumer company, right? Because there's benefits that I'll get. I mean, you can think of really simple things, like if somebody had some horrible infectious disease, I don't know, Ebola or whatever, and they were running around the town of the city of Munich, and the government said, gee, if we had your cell phone data, we could tell if you were exposed. That sounds good. Okay, yeah, you should have my data. I understand that. On the other hand, one can obviously understand that doesn't mean I want you to have all my data all the time for whatever purpose you want. And the problem today is it feels like they're boxing us into an extreme that I don't think works either way. Either give me all your data all the time and trust me, because we've seen that doesn't work. And I don't think it doesn't work because people aren't trustworthy. I think it doesn't work because I think 99% of the people in the world are good. I really do. I live in this very hopeful place. But that means if you have a large group of people, by definition, there's like one person at least that can't be trusted, and they had access to your data. So that's a problem, right? So it's not about people being bad or being evil. It's just the vast majority are, but that doesn't help me. Right? I look at the other side, the answer is, well, then I just encrypt everything. Well, that's fine, except there are a lot of times when that's not to my benefit. Me as a society, I like living in a community. I like to have their benefits. I want you to do some things with my data. And how do I choose? So we're looking at some new technologies. We'll see how they go. So like all DARPA things, we start with a high vision of, well, what would be ideal? And we ignore everybody who tells us it's impossible, right? So that, they told us the internet was impossible. They told me Siri was impossible. They told us stealth was impossible. They told us driverless cars were impossible. And that all comes out of DARPA. So we just sort of ignore that part. So here's the two things I think, and you should be part of the conversation. One thing I hear is, look, I don't mind giving somebody my information, but I want to know who I gave it to, and I want to make sure it only went to them. So let's take like the infectious disease example, okay? You say you're from the health minister. I want you to have my data. That seems good. You should have it. But that shouldn't go to the tax service, and that shouldn't go to the police service or whoever else. I mean, you told me that was going to you, and I agreed to that part. So that's one circle one can imagine putting around it. The other circle is time. Well, just because I gave you my data for some purpose doesn't mean I meant you to have it forever. So what if I could limit it for 30 days or 60 days? And again, excuse me, I'm not talking about trust. I'm talking about like the data would physically not be there anymore. At that point, we can start to have a real sort of societal conversation which says, okay, now that sort of seems fair. If you could, and I think DARPA's role, if we can do this, is to provide people with the technological confidence of here's the code, it's all open, it's published, you can look at it. Here are the mathematical proofs that come with it that will give you some confidence that says, these are some restrictions we can put on the data, and then everybody as a group decides whether you want to use the technology or not our job. But at least we've gone from
people just sort of, with no technical expertise, just sort of flailing their arms and making sort of crazy statements to, let's talk about what's possible, and let's talk about what we can do, and then let's, as a society, agree what we want to do to move forward. And every country may be different, right?
I think you've just taken a really strong position on data sovereignty at the individual level, because what you said is, okay, I will completely own my data, but I can make a decision, here's data that should be shared with the health department or shared with the government, and how long it does. But what you're kind of saying is, I get to make that call, which would be very different than the health department or the NSA by fiat saying, well, in this case, I need to get it. So how does that, like,
well,
who gets to make the call seems to be a big issue here.
So I think it's like all things. And again, I'm not the policy guy, so I don't know. But my gut is, one, I want to provide the technology so that at least you could do that yourself. And then it's like every group and every society has to decide, right? For the most part, you think about anything. My home, right? My house is my castle and you're not allowed in. But then we have certain rules. We say, oh, but if it's on fire, I can't just say, no, don't come into my house, right? Because other houses will burn. So, but I think a society will decide that. The difference is what I'm trying to do is at least give us the ability and the power, one, to protect your data. The second, which is actually very important, and I don't think people understand today, is the amount of data leakage that you have. I think people are completely unaware of the amount of data that goes out there. So you can't even make an intelligent decision. So I don't know if this applies in Europe, but I'll give you an example that I do know is true in the United States. It's just a fact. Let's say you go on some website, nice commercial website, very reasonable, and they say, hey, we're just doing a small thing. We just want to know if you're a male or a female. Were you willing to answer that question? And you think, yeah, I'm confident in that. Sure, why not? Okay. A few days later, you go to another website. You don't know. It happens to be owned by the same company, but different website. And they're sending out a free something that you want. And so they need. So they say, hey, can we have your zip code? And you think, well, yeah, you can have my zip code. Just that sounds reasonable. So zip code for you is like your area code, right? So you can have that. Okay, fine. Now a third company says, gee, we're going to show you something, but it's for more mature people. So we need your date of birth. So you give them your date of birth. Now you probably don't think you've given out all that much information. 3 different instances, 3 different things. At that point of data, you can identify 87% of Americans to the person. And so part of it is to make people aware of what it is, to start to understand the decisions that they make, and then have some ability to do something about it. There's nothing more frustrating than me telling you what can happen to you and then saying, but you're screwed. Like, don't tell me then. So we're gonna try to empower people to do things.
Tobias, it sounds like Dan here has this incredibly reasonable relationship with the American hacking community. They go to DEF CON, they have computers that take things on, but at the Chaos Computer Club, I think you have a different perspective on where your relation is with the government. So I'd love you to distinguish that a bit for us.
Well, at least what I heard in American with American conferences, there's always lots of government or agency people around trying to recruit. And so at least here in Germany at the Chaos Computer Club, we don't tolerate that. So but other than that, I completely agree with Dan. I think DEF CON already, they shut out government people a few years ago, right?
Yeah.
That's a great story.
DEF CON is an amazing conference. And a few years ago, we used to go every year. And we were supposed to give a big conference. In fact, I don't know if people know Mudge, but Mudge used to work for me as a big hacker. And after Snowden and a bunch of stuff, DEF CON said, no government people, we're going to stop it all. And we wanted to be very respectful of it. But I kept looking at the program, and a bunch of us supposed to talk. So call up the organizer and said, hey, I know you may forget because we're sort of different, but remember we are part of the government and we want to respect that. And I somebody said, yeah, no, but it's DARPA. You guys are different. So we have this odd relationship, both with the academic community and I think with other people. And I think it's because we're not operational, right? We don't do things. Like we wouldn't go and then just recruit people or go do things. It's sort of, we're 100 little nerds running around from everything from bioscience to materials that are just interested. I think that's part of it. And part of it is because we share everything. Right, so if anybody's curious about any of the stuff I talked about today, just go. There's a DARPA open catalog. We publish every article that we fund, almost every piece of code, literally GitHub repository. You're welcome to the code. You should use it. The idea is to try to make the world a better place. Obviously, you know, in full disclosure, there's a few things we do that are obviously in the classified realm, but for the most part, we try to make it open and available to people.
I want to wrap up with one more story, which is in this whole theme of only just beginning, a great way to give us insight into how much work is to be done is the work you're doing on human trafficking, which presents a very interesting information management problem.
Yeah, so that's the other half of my office. One of my program managers, Chris White, was at a conference on human trafficking, and he heard a statistic that shocked him, and me too, that the average cost of procuring a woman is $90. Yeah, and Chris feels like I do, that if you hear something that repugnant, and you have a technological ability to do something about it, you have a moral obligation to do something about it. And he came to me and he said, we have to fix this. And I said, okay, well, do you have any ideas? He said, no, but I don't care. We're smart. Do something. So we went out and we went to law enforcement. We went to NGOs. We went to outreach groups, victim outreach groups. And we watched what they did. And it was very sad because they're diligent, hardworking people. But what they do is what you and I would do. They get onto Google or Bing and they have one phone number and they type it in and then a website comes up. And then they read it and then they scratch on something on a yellow paper, you know, yellow sticky. And then they click on one website and then they write something down and they come back and they're trying to figure something out. And you realize that, you know, there's something like 65 million ads. And, you know, and you just picture it's like people, you know, one grain of sand off the beach. And we said, okay, we have to change this. And so we've invented a program, you can look it up if you want to hear more about it, called MEMEX, M-E-M-E-X. And MEMEX is trying to develop an entire new way of doing search, domain-specific search. And the idea here is to create what we call a data wake. So the idea is, you clicked on one website. What you probably don't know is that website gave you maybe 20 or 30 other places you could have clicked on if you had infinite time, but you don't. And then you went to another website, and now you've created hundreds of websites that you could have gone to, but you never went to. What our software does is it not only does it map all of that, it then pulls out of it and says, here's something you probably never would have seen. But 17 of these all use the same phone number. And it completely changes the frontier of investigation. It allows you to see stuff. It also allowed us to see stuff that is not indexed on the web. So the web is very shallow, right? So you don't see very much stuff. So anything that's behind a web form or anything that's on social media is not seen. We invented a crawler that actually allows you to get to all of that data. And we're putting that, again, very openly. So that's being used. I'm very proud of this. It's actually being used right now in New York. They have 26 indictments and 1 conviction already using our software, so it's really nice. But it's also simultaneously provided to all the victim outreach groups, groups like Walk Free, and whoever wants it, you know, have it. And we've just started, so hopefully give us a year, it'll be way better. I mean, it's good now, but if I can end this scourge before I leave DARPA, I'll be a pretty happy guy.
Gentlemen, thank you. We're wrapping up this conversation and wrapping up a DLD, and this theme of it's only the beginning. I mean, in many ways, what you're pointing out is now that we're living so much of our lives online and we rely on all of this stuff, the security and the trust that underlies it is kind of the great heavy lifting to be done. We talk about the need of focusing on infrastructure and stuff we trust, and this seems to be the core of it.
Well, I think the goal is it's all of our responsibility. My job is to make tools and make it easy and accessible so that we can do the right thing.
Well, thanks. I'm going to turn it back to Steffi to bring us home, and thank you very much.